Hello mathematicians, today's objective is students will be able to perform unit conversions using dimensional or unit analysis. Get that down. Okay, real quick background on this. This is a tough objective. This 120B and 120C, some of the toughest of the year. You will need to understand this for both math and science, freshman through really senior year. Last year we met with the sophomore math and science teachers and we all decided we're going to teach it the same way. So this is something that you've got to push yourself to understand. Okay? Now, let's start with a basic understanding. If I give you the fraction 4 over 1, okay, what fraction could you multiply this by so that the 4 in the numerator here essentially cancels? Again, what fraction could you multiply this by so that the 4 in the numerator cancels out? Okay. Well, you should be thinking, if there's a 4 in the numerator, I would need a 4 in the denominator for it to cancel. Because when you would multiply those out, 4 times 1, so you multiply across, 4 times 1 is 4. 1 times 4 is 4. 4 divided by 4 reduces to 1. So how do we get something in the numerator, in the top, to cancel something? Then we basically multiply it by something in the denominator, the exact same thing. Okay? Alright, let's get to the steps for today. I want you to take about just 30 seconds and just glance through those steps. I don't expect you to memorize them. We're going to apply them here in a minute. Okay, hit pause. Okay, hopefully you've glanced through those steps. Here's an example of the type of problem that we're doing today. Marlon ran a race in 2.5 hours. How many seconds did it take him to run the race? Okay, essentially, we're starting with hours, right? That's what's given. And we need to go to seconds. So right here, again, we're starting with hours because that's what's given. Okay, and we're ending at seconds. That's what we want. Now the question is, and this is one of the toughest parts of this objective. The question is, do we know the conversion between hours and seconds? I mean, do you know how many seconds are in an hour? Okay, and off the top of my head, I don't. So I'm thinking, well, what do I know? Okay, what comes after hours that kind of leads me to seconds? Okay, and you should be thinking minutes. You do know how many minutes are in an hour, and then you do know how many seconds are in a minute. So our pit stop, okay, this is what I'm going to refer to as a pit stop. Do we need to stop anywhere in the middle? And what we need to do is ask ourselves, like, do I know the relationship between my starting and ending units? If you don't know that, you got to make some pit stops. Okay? Alright, let's actually go ahead and do this one. You should have a little bit of room underneath, just you're going to have to write small, just right underneath this line in your notes. You can also do it right up here if you want. I'm going to write down here because I have a little bit more room. Okay, so let's write 2.5 hours. Okay, now how do we write anything as a fraction? If I just give you 2.5 hours, how would you write that as a fraction? Well, we can write anything over 1, right? If I give you the number 152, how can you rewrite that as a fraction? 152 over 1. Okay, so now we already have our roadmap. This is what we call our roadmap right here, the hours to minutes to seconds. Okay, we are going to write the conversions. Okay, so we have hours to minutes. That's our first one. We got that right here, right? Hours to minutes. Well, I know that 1 hour has 60 minutes. Okay? And then minutes to seconds. Well, I know that 1 minute has 60 seconds. Okay? So we're going to, once we have our roadmap, we're going to actually write those numbers and those relationships. Again, what's the relationship between hours and minutes? What's the relationship between minutes and seconds? We have that right here. Okay? All right. Now, do we want to keep hours? The answer is no. We want to convert it to seconds. So we have to cancel the hours. Okay? Now think back up here to this 4 times what fraction? If hours is in the numerator, where do we need hours in this second fraction that we're multiplying by? And the answer, we need it in the denominator. Because if you have hours on top, hours on bottom, it will cancel. Okay? Now look at your roadmap. After hours, we said that we were going to what? Well, we said that we were going to minutes. Therefore, we put minutes on top in the numerator. Okay? Again, we look at our roadmap to determine what comes next in our fraction. Okay? Now, do we want minutes? Does our final answer want minutes? And answer, no, it wants seconds. So we need to cancel minutes. Well, if you have minutes in the numerator, how would you cancel it? You need minutes in the denominator. Minutes on top, minutes on bottom, gonna cancel out. Okay? What comes next in our roadmap? So again, the question is, what do I write for units in the numerator? Well, look at your roadmap. After minutes came seconds. Okay? Now, the question is, do we want to cancel out seconds? The answer is no. The answer wants seconds. So once you get to the units that the question's asking for, circle it and write equal to, because we're done with kind of setting up this long fraction. All right? Now, go through and fill in the numbers. So one hour, okay, 1 goes with the hour, is equivalent to 60 minutes. Okay? And then we also have the next relationship. 1 minute, so 1 goes with the minutes, is equal to 60 seconds. Alright? Now we have all of our numbers. And let's look at our units. What's going to happen with hours over hours? It will cancel. Show that those cancel, and don't just start crossing out the same units. Actually think, do I have minutes in the numerator, minutes in the denominator? If so, those will cancel. Okay? Now, we just have a long fraction that we're multiplying here. How do you multiply fractions? You multiply straight across. So on your calculators, do 2.5 times 60 times 60. And you should get, I believe, 9,000. Now, are there any units in the denominator? And the answer, yes, the seconds, right? So it's 9,000 seconds. And then in the denominator, we have 1 times 1 times 1, which is clearly 1. Do we have any units left down there? The answer is no, because hours and minutes both canceled. So we could show this as 9,000 seconds over 1, or we can just show it as 9,000 seconds. Okay? Alright, let's go into a couple more examples. Okay, for example 1 here, because we just did that one, I actually want you guys to try setting this one up on your own. So a few things. First of all, make sure you start in the far upper left hand corner, okay, all the way up here. You're going to have to write small, and use the example that we just did to help you out, and follow it step by step. And again, the steps are up above now that you can reference, and you can use the example that we just did. Okay, so make sure you're using a pencil, because if you make a mistake when I go over it, you can go back and change it. So right now, you're going to hit pause and do it, and then you're going to check your work with mine. So hit pause now. Okay, to do this problem, very first thing that we need to do is make a roadmap. What units are given to start with, and what are ending units. And again, you guys really have to memorize the steps that we take and really internalize how we do each of these problems. If you do it the same way every time, eventually it'll just kind of click and you won't even have to think about it. Alright, hours to minutes. Do you know how many minutes are in an hour? And the answer should be yes. You know how many minutes are in an hour. 1 hour is equal to how many minutes? 60 minutes. Okay? Now that we have our roadmap and our conversions, we can start setting up our fractions. Again, we don't start setting up our fractions until we have those two things done. So let's just write what's given. We started with 3.6 hours. Again, you just write what's given. How would you write that as a fraction? You write it over 1. Again, we can write any number over 1. Okay? Now we need to make a conversion. We need to convert to minutes. So we need to get rid of hours. If hours is in the numerator, I know I need hours in the denominator. Look at your roadmap. So right up here, what comes after hours? So this tells us what to put in the numerator here of this fraction. Well, we said that we were going to minutes next. Okay? That's the unit that we want. So we circle it and write equals because we're done setting up these fractions. And now fill in your numbers. You notice I'm not filling in numbers until I'm done writing in all the units. So 1 hour is equal to 60 minutes. Okay? Now, unit hours in the numerator cancel, hours in the denominator. Cancel your units. So now you can just multiply. 3.6 times 60 is, what was that? 216 minutes. Now, 1 times 1 is 1. No units in the bottom. Do I need to show 216 minutes over 1? No. That's your answer. Alrighty, let's do example 2. So we are given minutes now, and we want to go 2 hours. Okay? So set up your roadmap. Our roadmap, we start with minutes, and we're going to hours. Okay? Alright, do you know, again the question, so we want to, do we need to make any pit stops? And to figure out the answer to that question, we ask ourselves, do I know the relationship between minutes and hours? The answer is yes, we just did that. Okay, there are 60 minutes in 1 hour. Okay, 60 minutes in 1 hour. Now that I have my roadmap and my numbers that show the relationship, okay, now I can start setting up my fraction. So in this one, I started with 35.8 minutes. How do you write that as a fraction? Over 1. Okay. Then how do we cancel minutes? Because we don't want minutes. How do you cancel it? Well, if minutes is in the numerator, you need minutes in the denominator. And it's going to hours. Okay? So, hours is what we want. We circle it and write our equal to sign. Now we can fill in our numbers. Okay, now, and the last one, 60 went in the numerator, right? The number 60 went in the numerator. But you have to look carefully. 60 is paired with what? 60 minutes. So 60 has to go with minutes. Okay, and the 1 goes with the hour. Okay. Now, cancel out your units that cancel. Minutes on top, minutes on bottom, cancels out. Now just multiply across. 35.8 times 1 would be 35.8. Your units in the numerator are hours. Okay? And then the denominator, 1 times 60, is 60. Do you have any units down here? The answer is no. Your minutes canceled. So now we simply have to divide. Okay, so 35.8 divided by 60 will give you 0.5, what is it, 96 with the 6 repeating. What are the units? Well, the units are hours. Okay, and notice when you circle, make sure that you don't circle over that repeating bar. Okay. Alright, let's go on to the next example. Okay, go ahead and use cups on this problem and think about what do you know about this problem? What are some key words? How do you think you would set this up? Okay, by now you should have used cups. So let's go over this together. One Saturday she used 18 ounces of yeast to make 6 loaves of bread. Now, you should, as you read that, you should say, well, those numbers have a relationship. It took 18 ounces to make 6 loaves. Okay, you have to see that those two numbers have a relationship. The question is asking, how many cups of yeast would it need to make 18 loaves of bread? Okay. Now, what's going through your head as far as how you could solve this problem? Okay. When I see this, I see, well, these two numbers have a relationship. I have a third number given, and I'm trying to find a fourth number. Okay. Right away, you should be thinking USA. This is a proportional relationship, and we use the USA box, okay, to show those proportional relationships. So start all the way over in the upper left-hand corner. Okay. So, what are units? Well, we started off with ounces, which we abbreviate OZ, and the other unit is 18 ounces of yeast to make 6 loaves. Okay, those are the two units. So, fill in the numbers. It took 18 ounces to make 6 loaves. Okay, and the question is asking, how many cups would it make? What do you need to make 18 loaves? So the 18 goes here with loaves. Now, you may be thinking, well, Mr. Erwin, it's asking cups, and our units that we have here are ounces. Okay? But here's the deal. If we figure out what ounces is, how many ounces, then we can simply convert that to cups. Okay? So we're just going to go ahead and find out, well, how many ounces that would take, and then we'll convert that number to cups at the end. Okay? But I would put a note here, okay, that we need cups. Because the number one mistake is for students to just solve for that number and then say that's your answer. But that will give you ounces, not cups. Okay? Solve this proportion now. So I hit pause, solve this proportion. Okay, when you solve this, you get 54. Okay? And that's 54 what? That's 54 ounces. That does not answer our question of cups. So, we simply need to convert now. Okay, what do we need to convert? We have ounces, and we're going to cups. Okay? So now you have to ask yourself the question, do I know the relationship between ounces and cups? Okay? Look on the front of your notes packet, page 1. This is ounces and cups. It's talking about capacity. Cups is definitely in the U.S. standard system. So see if you can find the relationship between ounces and cups. Okay, so hit pause, see if you can find that now. Alright, hopefully you found it. There is a relationship, so we do not need to make a pit stop. The relationship is, okay, 8 ounces, okay, is equivalent to 1 cup. 8 ounces is equivalent to 1 cup. So now that we know that we have our roadmap and we have our relationship with numbers, we can start setting up our fraction. So 54 ounces. Write it as a fraction, so put it over 1. Okay. How are we going to cancel the ounces? Well, if ounces is in the numerator, we need ounces in the denominator. Our roadmap tells us after ounces, we're going to cups. So we put a C in the numerator. Now we can fill in our numbers. The 8 goes with the OZ, so that's got to be in the bottom. 8 ounces, and then the 1 cup. Okay, and I forgot we need to circle that and put the equal to sign, because cups is what we want. Now cancel your ounces on top, ounces on bottom, and then you can just multiply across. Okay, so 54, and then cups is still left here, and the numerator. 1 times 8, no units, would be 8, And then if you divide 54 divided by 8, you get 6.75. And let's write it out kind of in words. It's 6.75 cups to do what? To make how many loaves of bread? To make 18 loaves. Okay, so that would be your answer. Okay. Alright, let's do a couple more examples. Alright, let's look at this problem. Find this one in your notes. Okay. 7.8 liters to milliliters. Okay. Now, take a look at this carefully. What do you notice about it? Okay. You should be saying, oops, I spelled that wrong. Should be 9. Okay, you should notice that both of these, and you can actually write it above it, both of these are in what system? Okay, and again, you guys have a room above this. They are both metric. Both of these units are in the metric system. What should you be thinking if they're both in the metric system? We covered this in 120A. You should be thinking King Henry. Okay, so write it out. King Henry died unexpectedly drinking chunky milk. Where are we starting at? Well, we're starting with liters. Where is liters at? Okay, well, liters is under the U, which stands for the base units, right? Meter, liter, gram. So that's where we're starting, and we need to go to milli, which is right here. How many steps is that? Well, that's 1, 2, 3 steps. So I simply write out, again, this should all be review, 7.8, and then I need to move the decimal 3 places. So 1, 2, 3, big decimal, fill in the empty loops. So 7.8 liters is equivalent to 7,800 milliliters. Okay? Make sure you rewrite it using the comma. You would never circle this as your final answer with all those ugly loops. Okay? Alright.